what is the current status of meta-analysis? Is it trustworthy? Should practitioners be looking at it? What are the alternatives if we don't think it's up to the purpose? Where does that leave us? How do we convey uncertainty or caution without undermining any benefits that evidence might have? Those would be some of my questions, but I'm sure you'll have your own questions and no doubt better ones. So maybe we'll start with you, Steve, if you could just introduce yourself and say a few words about your position on all of this.
Okay, I'm Steve Higgins. I'm Professor of Education here at Durham. I'm responsible for the upkeep of the Education Endowment Foundation's Teaching and Learning Toolkit. So I have a particular interest in not just meta-analysis, but trying to aggregate messages across meta-analyses. There's I think much, if not all, of the objections that Dylan raised that I agree with, and I'm aware of the limitations of meta-analysis. But as he said at the beginning, I don't see any other alternatives. I've likened the toolkit at the moment, to being like a mappa mundi, a medieval map of the world that gives us ideas of the general shape and picture. But until we bottom out on the issues that Dylan raises, we won't be able to understand fully the comparability of the inferences that are drawn. And that's why I have a strong view about describing the toolkit as what's worked, past tense, again, as Dylan indicated. And also that at the moment it gives us our best bets for what the evidence says at this point in time. So I think we have a choice. Do we say it's not trustworthy enough at all to take any notice of because of the problems that Dylan identified? Or do we say this is our best bet? These are the inferences I think we can legitimately make at the moment until we effectively unzip all of those meta-analyses and put them into a single giant database which would allow us to explore the variability that Dylan suggested. I think we're better off using what we know and trying to improve that than pretending that we know nothing at all. So that would be my current position.
Okay, thank you, Steve. Ben.
Okay, so
sorry, can people at the back hear okay? Is it? Yeah, good. Sorry, carry on.
Okay, so I'm Dr. Ben Stiles. I run the Education Trials Unit at the National Foundation for Educational Research, NFER. And I'm interested, obviously, in the first stage of this process, the generation of the individual effect sizes. And I think Dylan's presentation covered some of the problems with that first step, but I would argue there are a few more actually, which we need to think about carefully. So he covered cross-level comparisons. He covered variation in variability by age. When you run a multi-level model at the end of an experiment, there are all kinds of different ways you can calculate effect size, because the denominator of that calculation is the measure of variability in the outcome, and that's another reason why you have to be very careful about what effect size you're comparing. You also might be tempted to combine two studies which have measures which have very different reliability, which would also contribute to the variability potentially in the outcome that you're trying to combine. These two measures might be of different reliabilities, and there's a recent paper written by Adeteo and Peter Timms here today, which looked at the difference in variability between around the intervention and the control group in a randomized trial, which might then also influence the size of the effect. In fact, this can give rise to the phenomenon of effect size being non-transitive. So the idea that for a standardized effect size, you might have study A being larger than study B, but then for a non-standardized effect size, the reverse is true because of this phenomenon of change in variability between the groups. And these are all things we have to be concerned about. Again, we've heard from Adrian Simpson already today, but he would argue that they cannot be meaningfully ordered, they cannot be compared, and they cannot be combined, except in the very restricted set of circumstances where raw effect sizes would work anyway, which Dylan alluded to. So we've got to think about these problems very carefully when we're trying to combine them. And, meta-analysts have a very difficult job, particularly when that kind of information isn't actually included in the paper that they're meta-analysing. I would argue that because of the benefits that we get when we combine, that providing the measures are sufficiently similar, the interventions are sufficiently similar, that we can make these combinations to our advantage. On the issue of whether the intervention group changes the variation in the outcome, well, if that's a uniform effect across all the interventions and studies that you're combining, well, then that would remain legitimate in terms of its combination. So I think what we'll probably learn from today is that we just have to be incredibly careful when we're making these combinations. And I would add one further caution, which is that because of the replication crisis, and because only recently studies have been insisting on pre-publication of statistical analysis plans, for example, that we should be incredibly careful about the studies which we are including, which is why EEF are absolutely right to be unzipping their toolkit. And what we don't want is a situation where we have robust randomized trials going in, which might be even them vulnerable to the replication crisis, and then other studies which are less robust, which could be even more problematic. So we just have to be incredibly careful about what we're putting in.
Okay, thanks, Ben. Nancy.
I'm Nancy Cartwright. I'm a philosopher of science and methodologist. I've worked a lot over my career on causal inference and causal modeling across both the natural and the social sciences. And I'm really the odd one out here because I think that the meta-analysis program is embedded in a way of thinking about evidence that is extremely limited and mistaken, to put it bluntly. So looking across the natural and the social sciences, I think that the best reconstruction, if I want to give a reconstruction of how it is, right, that results that I would myself happily believe in, how these results get stabilized, I think the best reconstruction of the methodology that's going on there is it's the old-fashioned hypothetico-deductive method. And it's not what we're seeing in the whole enterprise in which meta-analysis is embedded. So in the hypothetical deductive method, you've got a hypothesis that you want to test. It could be a hypothesis about how big a quantity is, like my body mass index, or it could be a hypothesis about some fundamental equations, like Maxwell's equations of electromagnetism. But the idea is still the same, that to have robust evidence for this hypothesis, you look to see what kinds of things would be true if this hypothesis were true. And you want a large number of them before you come to stabilize that hypothesis and think that's really worth putting on the books and teaching other people about. You want a large quantity, you want a large variety of different kinds of predictions that the hypothesis makes, successful predictions that it makes. And of course, what counts as the right kind of variety depends quite a lot already on a lot of assumptions that one has to import from elsewhere that doesn't have quite to do with that hypothesis. Okay. You want the hypothesis to make Ideally, novel predictions, ones that you just didn't know about already. You don't want it just to accommodate, and you'd like it to make predictions that that differentiated it from the plausible alternatives. So those are four things that I look for. I look for the hypothetical deductive method. I look for the this array of different kinds of evidence that the hypothesis implies. Of course, in order to get it to imply sort of dramatically different things, you have to embed it with a number of other hypotheses. So, I mean, in order to get my body mass index to make a lot of different predictions about things you'd expect to see, you have to import different premises, and the whole point is to get different premises that might be mistaken in different ways. But you do need to then import these other premises. We're very reluctant to do that because this, that involves knowing whether or not having some trust in whether these other premises are reasonable or not. But that seems to me that's the way in which normal science proceeds when it stabilizes results that I'm happy with. And I don't see that happening at all in the community of work that involves doing trials, randomized control trials, or comparative studies, and then doing meta-analyses over them. That's fine. There's all the problems and also all the advantages that if you've got statistical studies, this might be the best thing we can do and we want to improve it. But the kind of evidence that is being reviewed is just a drop in the bucket of the kind of evidence we should be looking at and we should be gathering. And I think that the emphasis on, this whole way of looking at it is absorbing time, energy, money from the enterprise we really should be doing, which is this richer evidence production that's required. The last thing I'd like to say is that since I've spent a long time doing causal inference and causal modeling, I'm also astounded that it seems to me most of the work that is in question here are hypotheses about causal relations. Do interventions, have interventions caused certain outcomes? Will they cause certain outcomes? Do they generally cause certain outcomes? So it's causal testing we're interested in, and somehow or other we've ended up in a value where we're just looking at statistical inference, and causal claims are not probabilistic claims. Causal claims are causal claims, and they, in the right circumstances, sometimes have some implications about probabilities, but there's lots more to the metaphysics of causation and epistemology of causation that allows us a lot of inroads into testing causal hypotheses and using them in the hypothetical deductive method that's got nothing to do with statistics and statistical inference. So I'm just, as I said, the odd person out by thinking we're looking at, we've got focused on a tiny bit of the evidence we should be generating and looking at. And I don't really have anything positive or negative to say about meta-analyses themselves, but that the whole enterprise is distracting from what we should be doing.
Thank you, Nancy. I suspect you're not the odd person out at all in that view, actually, and I think that's a really interesting challenge. I can't quite resist a little personal anecdote. I first came across your work when I was interested in the philosophy of, partly encouraged by Dylan, actually, in my PGC years, reading about the philosophy of science and the philosophy of mathematics, and various work on that. And I came across this really cool philosopher of science called Nancy Cartwright, and read some of your work and thought, wow, this is really hard. I'm not sure I understand all of that. And then about sort of 20 years later, actually met you. And people say never meet your heroes, but it was one of those kind of, wow, I'm actually meeting this person. And but that was I wasn't disappointed in any way. You were far greater than what I expected. So it's wonderful to have you here and expressing that view, which I think is, as I say, I think one that people will welcome, and it's a bit odd that we've got to this state, isn't it? And so this was going to be my question to the panel. So we've heard a lot of criticisms of how meta-analysis needs to be better, how Nancy's saying there, really we've kind of forgotten the scientific method actually, and we're focusing on these nitty-gritty little bits and lost the bigger picture. Well, you guys are the researchers. This is the researchers panel. So do you need to up your game here, or how are we going to address this?
I'll give that a go. I think, I take those criticisms. The problem is, how do you design a coordinated approach to the sort of hypothetical deductive method that you're envisaging across such a diverse educational ecology? And I guess my view is, we're here now with what we've got. Let's try and keep going in the direction and see where we end up. I can't quite see how we start Nancy's enterprise. I can't see where we go to do what she's envisaging, and that's my issue. I absolutely get that, but I'd rather use the evidence we've got to try and generate hypotheses that would then be testable on the basis of synthesizing what we know currently, than throw all of that away and start an enterprise that I just can't see how we get going. I can't see how we get funders to agree to coordinate their research. I can't see how we get schools to be part of that process, because it just strikes me it's a very different position than science was perhaps 150, 200 years ago when that enterprise began.
So
anyway,
start from here.
Yeah, I want to start from here.
Could we just classify how different, though? I mean, you're not rejecting randomized trials, you're not rejecting the replication of studies, which I think there could be more of, presumably. You're accepting those things?
I'm accepting that a very well done randomized controlled trial in an area where you have enough knowledge to control for post-randomization confounding, which is really difficult, that those can establish whether a cause produced an effect for some individuals in the study population. I think that's, I can actually do a logical proof that making the assumption that we have genuine orthogonality and some simple assumptions about causality and probability. It's just deductively, I can prove deductively, right, that in a randomized controlled trial you get an unbiased estimate of an average treatment effect. So don't reject that. Don't reject that. You might want to have that across different populations. Yeah. But that's like making, that's a tiny bit of what you'd want to do. Now, if the hypothesis is, what hypothesis comes out of that? And if you don't have, this is why, can I?
Yeah, of course.
I don't know why it's, but it seems to me that if you don't have enough thick practice and understanding to figure out what your hypothesis. You've done I'm happy you've done work, you have a hypothesis now that something you're very careful about, it has worked a few places, maybe it will work in these kinds of places. Yeah. If that's your hypothesis, that's a causal hypothesis. Yeah. And if it, apart from just going and seeing it over there, if that's the only implication it has, I think that you're in a very, very weak position, and I don't know why you're doing it in the first place. Right? That's what I worry about, is that if you don't have enough, or you're not willing to make some bets on, other kinds of information you can feed in with it to see that it makes a set of predictions that you can test out. That if you don't have that additional rich stuff going on, then this is an isolated fact that we're pretending has more power than it does. So I'm very happy to start with those as hypotheses. Yeah. I don't want to bother with them unless I can do something with them other than just say, let's try it out over there.
So without it multiplying into something completely unmanageable, wouldn't we have to just severely restrict the number of hypotheses we were making?
Sometimes you do. You usually test plausible ones against each other, but in this case we're much more interested probably in is it likely, the hypothesis about the causal connection. There's another thing you can do, which is these are causal hypotheses, and we all, talk about theories of change and understanding how the intervention is supposed to bring about the effect. But once you've got a plausible, really worked out theory of change, it generates a ton of additional hypotheses.
Yeah.
Right? So, does this step is supposed to prove that one, is supposed to cause that one, is supposed to cause that one. Each one of those is itself a causal hypothesis.
Yeah.
It can have side effects, symptoms. There can be theory that backs it up. And I think our problem would be, at least two, come to understand and be able to accumulate the evidence there and to synthesize it. And that's not going to be synthesized in a meta-analysis because it's not very, very, very much of it is not statistical. But we have even, in our toolkit now, your toolkit, and the kind of tools we know how to work with, we have additional sources of evidence about these causal claims that I think we're not making sufficient use of.
Yeah, and I certainly agree with that, in that having a theory of change that is tested through the trial, particularly collecting evidence that might falsify that, would be a really big step forward in designing EEF trials. So you think about what theory of change you've got.
Yeah.
What we tend to do at the moment is think about collecting data that might be consistent with that theory of change, but it's also important to think about what data might contradict and falsify that theory of change. And that, for me, would be one of the ways that we could step forward.
My view is not just to think about data,
Yeah.
right?
Yeah.
But there will be hopefully some theory behind why each step is supposed to lead to the next.
Yeah.
Now, it's hard if you've got an idea about meta-analysis, you can't conceive of how you can add claims about theory into mixing it with claims about data, mixing it with claims about sort of side effects that aren't really probabilistic. How you mix all those together to come up with a synthesis. And that's the normal problem of life in science. And we do it all the time. It's just hard. So
Okay.
we should stop
That's great.
focusing on
I
what
think
I
that's
said.
really interesting. We've got time to open this out, so I'd like to open it out to any comments or questions from anybody. Questions to the panel, perhaps, or
Should we have Dylan here too?
well, I think if anybody does want to ask a specific question to Dylan, then they're free to do that, or to Larry even, or to anyone. But let's get some discussion going. So who's got a question or comment? Yeah, David.
Question to Dylan, but the panel. One thing Dylan did, the problem he didn't raise in his presentation was down the line fraud. I work in my main work in the health sciences, and I had one of my most highly cited papers was a meta-analysis of vitamin K supplementation, and it's been cited in national international guidelines for prevention of treatment of osteoporosis. Unfortunately, about 2 years ago, we discovered that half the papers in our study were fraudulent. They were badly done. They were made up. The information was completely made up. And then the story gets very interesting. So I wrote to the journal, so I hope our medical journal. I'm the corresponding author. It's my paper. And I asked the journal to put a notice of concern about our paper because some of the analysis wasn't affected by the fraud. The main point was, and we also did a reanalysis of excluding fraudulent paper. It took nearly 2 years to get the journal. Not the journal has to investigate anybody. It's my paper. I'm saying, can you withdraw it or suspend them? It took nearly 2 years for them to actually do that. So we've done other work that shows that there's quite a bit of work now in the health saying that an unknown proportion of studies that contribute to meta-analysis could be fraudulent. And if it happens in health, I'm sure it happens in everything.
Okay, and Dylan's going to solve that problem for you.
I think that I just assumed that, like most other educational researchers, that it all stopped with Cyril Burt.
Right.
I mean, it's something I haven't thought of, and I've just blindly assumed that people at this part, this end of the academy, are not that interested in fraud. because it wouldn't do them any good. But I could be completely wrong about that. Just naive.
Steve.
Yeah, I think we just don't know. I think some of the incentives for fraud are lower in education, certainly economically, but you've got people's reputations, you've got a lot of evaluations that are done by the proponents of the program themselves. Then you've got doctoral studies, where a lone researcher has perhaps controlled the data set. So I think we have to consider the possibility that it occurs. Like Dylan, I'm kind of hoping that it's not so much of a problem, just because the area is so interesting and, if you like, work is uncertain and we're genuinely trying to find out. But we might be being naive about that. I absolutely take your point. I guess you'd start to see some patterns if you had enough data. You'd start to see anomalies in the patterns of results relating to either particular researchers or particular kinds of research. So I'm thinking perhaps of technology studies funded by technology companies. You might see it. Some of the thinking skills programs, which are evaluated by the proponents themselves. So I can think of some areas where we might be able to look for anomalous studies.
We need to look, because it's only...
Oh, yeah.
There's a guy called Carlisle, and he's an anaesthetist, and he's got some machine learning that started to look at the baseline p-values of trials.
Yeah.
Because you can look
Yeah.
at distribute, you know what the distribution should be.
Yeah.
And if you're making up data is really hard,
Yeah.
there are ways to make up data. You can get a detective, but most people who make
It's
up data...
too difficult to do for most people.
Yeah, there was a select committee inquiry into research integrity at the Science and Technology Select Committee about 2 years ago, and they collected evidence on this, and I think the bigger problem is still it's not conscious fraud, but just not doing your analysis properly, not pre-specifying all of this sort of stuff, which I see as just part of the replication problem, and how if what EAF have done in fact is to much improve the requirements in education research for pre-specified analyses and so on, and if that if you're including a report and a meta-analysis that indicates you've done all this sort of machinery around ensuring your research is replicable, then that's got to be an indication that the research is more trustworthy.
Okay, thank you for that. Larry, did you want to comment on that?
I'd like to comment. I have two comments about this question of fraud, and I actually want to find out more about your story, David. It shows I'm pretty ignorant about some things that are happening out there. But one point is that the issue of whether the original research data is any good or not is an issue that affects meta-analysis, but it's not unique to meta-analysis. This is a question of whether the scientific literature is reliable, period, at a single study level. And the second point I wanted to make is that I definitely agree that outright fraud is probably rarer in our field, but the kinds of questionable research practices that researchers admit to, that we know are likely to influence the results that they get, I think that's a much bigger issue, and something that we as a field need to take very seriously, because the replication crisis, as has been mentioned, is kind of presents an existential threat to scientific research, period. It's not just meta-analysis, it's whether or not there's any special status to the work we're doing that deserves the kind of resources society lavishes on it.
I wanted to ask about the difference between, I realize fraud has to do with intention, but since so much in our statistical analysis and then in a meta-analysis depends a great deal on judgment and making judgments about what's comparable and what's not comparable, all the things that Dylan talked about. Isn't it a serious worry that if somebody else had done the analysis, it would have come out very differently, and that can or cannot be a matter of implicit bias? So I worry about not being able to separate the issues of fraud from just genuine
Yeah.
total differences in judgments.
Okay. Well,
that-
yeah, go on, you're going to mention that.
Yeah, I can answer that to some extent because the EF trials are all put into a single archive that, with colleagues such as Adoteo, we analyse. So we try and replicate the original analysis and then run a series of standard analyses. And there is variability in that, but that's relatively predictable. And in effect size terms, if you get down to 0.05, it's very hard to be more precise than that. But actually, first decimal place variation is relatively rare, and we can always explain, or so far we've always been able to explain by the choice of analytic method as to what causes that variation. But yeah.
Perhaps I'm just overimpressed by the worm wars, where 3 years later I still don't know what one should think about the original Kenyan data.
Yeah.
Oh yes, yeah. So as a statistician, our analysis plans have been increasing in length over time, because even when you specify what you think is the full detail you need, there are tiny little things like the exact data set, the sort of cut of the data that you're going to use, which maybe you didn't specify. So you get to the analysis and there's still something which you didn't specify. So my solution is simply to just write better analysis plans.
Okay. Dylan, you want to comment on
I was
that?
going to mention just what Nancy said there prompted me to think about Gelman's garden of forking paths. This idea that each decision needs to be taken, and clearly, in some cases, that decision might always favour
Yep.
the significant result.
Yeah.
And that's why
Yeah.
maybe I don't think I'm that worried about fraud, because that's an issue for disciplinary action. But whether the data is misleading because it's a series of random failures or a fraud or just ignorance, the data is still the data that we're working with, and that's the problem.
Well, okay, so no one's mentioned it yet, but there's a lovely Brian Nosek paper where they gave the same data set to 29 different teams and came up with 29 different effect size estimates. So that's quite an interesting challenge to meta-analysis, I think. And they're all, or mostly, just kind of sensible judgments that arbitrarily you might choose one or the other. Okay, there's a couple of people waiting. Gary, you were first, I think, then Jamie.
Yeah, I can't say this is something I read Professor Cartwright's article, which recently came out in Education Research and Evaluation, and you used the analogy of a nest. And I think what you're saying is that meta-analysis is one type of twig
Yes.
you would use in constructing that nest, but it's not the only type of twig that you would use, and you need lots of different types of material in order to create a robust and secure nest. And to mix the analogy that maybe with meta-analysis we've got all our eggs in one basket.
Yes.
Like what you did there, Gary, yeah. So
That's
is
just
that
how
a
I
question?
mix them,
Yeah.
yes.
But that's what it seems to me. We've got a lot invested in one particular approach, which on its own probably doesn't provide a securer basis for individuals to make judgments about how to go about things in their schools and colleges.
Okay, that's a comment, I think, rather than a question. Jamie?
On the issue of reliability, it just led me to think about the toolkit and that indicator strength of the evidence, 5 padlocks or whatever. And so I was just wondering, actually, I don't know what's behind that indicator. How do you arrive at 5 padlocks or whatever?
There's a technical appendix. If you have a look, it gives you the detail, at least that's subtly. But it's normed, I guess, is my warning, because we've effectively looked at the field and then ranked the evidence across from 1 star up to 5 stars. So that's the best we've got at the moment. That doesn't mean that's the best we should ideally want. So it's looking at the relative robustness of that at the meta-analytic level. So again, that's a problem, because you're relying on those meta-analyses being sufficiently robust, which, as Dylan has indicated, they're not likely to be. And when we do classify the meta-analyses according to whether or not they use Hedges G, for example, the analysis type, whether they've got specific search criteria, whether they've undertaken moderator analysis. So we've got some indicators of quality, but that doesn't necessarily deal with all of Dylan's problems. Again, ideally, what you'd want to do is go down to the individual study level and be able to classify studies, something more like a consort analysis, or use Prisma and have a really clear judgment of quality at study level.
Okay.
Just one brief thing there. My only reservation there is sometimes the things that we think count as quality at a theoretical level don't make much difference at an empirical level, whereas other things do. Medicine's recently looked at different quality scales and hasn't found a good correlation between the effect size or the effect and the quality scale. So I think we need to do more work on indicators of quality in terms of meta-analyses.
So even bad studies are fine. Peter.
Dylan suggested that if you get very large effect sizes in small studies, that it's because the small studies are of poor quality. But recent analysis of EDF data suggested that's found even when we're trying hard and getting the analyses right. And there's a nice plot by Slavin showing very small effect sizes for very large studies. And I wondered if the panel could comment on that and whether you really would take it as the small studies being of poor quality, and that's why you get big effect sizes.
I could take that. So my understanding is we're looking for a funnel plot which does this. So you have the larger studies with the smaller effect sizes at the top, and you have the smaller studies with the large and possibly negative effect sizes at the bottom, and it just needs to look symmetrical. Hugo did a funnel plot of EIF and IES studies in his recent work, and I was struck by the fact that because it's meant to be like that. It has to be because everything is published. But I think that what is potentially going on, even within EIF and IES, is because in the early years there weren't formal statistical analysis plans. There might be a little bit of kind of publication bias within the study going on, because the funnel plot didn't look completely symmetrical. But that would be what I would expect.
Okay.
I'm not sure I agree. I'm not sure a funnel plot is a good way to assess publication bias. Lee Cronbach introduced the idea of superrealization bias, which suggests that it may be something to do with the quality of human relations in a small study. You can communicate more effectively, you can get the approach done more reliably. So actually in a small study, it may be the effect is genuine. Whereas it's harder to do that at scale, working across 50 schools the way EF does. The quality of interaction between the developers and the schools is obviously going to be much less, so you might expect to see a reduction of effect. So I'm not convinced you'd expect to see a symmetrical funnel plot. The other reason is I think education's ameliorative. We don't choose interventions randomly, if you like. So you might not expect a random but a distribution that would correspond to that, because we're trying to make things better. So you might expect to see overall a positive bias in the distribution, but again, until we start to bottom out on these issues and start to explain variability by sample size and try and work out, as Nancy's arguing, whether some of the implementation factors aren't actually responsible for the reduction in effect size, then I'm not sure I'd want to jump straight for the funnel plot or that distribution, or assuming it's a simple sample size, effect size relationship. I think it explains less than half of the variation in Slavin's work. So there's other stuff to look for, I think.
Okay, that's interesting. I think that sets the foundation for some of the later discussion with the other panels who talk about scalability and practical significance and all those kinds of issues as well. So hold on to that thought. Carol, you had a question.
Yeah, I had a question for you, Dylan. Like others, I agree with all of the problems that you highlighted, but I don't think it was a counsel of despair. And certainly we've had previous discussions about some of the issues you've raised, and I wondered if you could reflect a little bit on what I think is a key one that we might do something about in the UK, and where they are doing something about it in the US, which is on the outcome measures. And specifically, if you look at the EEF funded research, they're not doing anything to fund new outcome measures, to find more suitable outcome measures, more outcome measures that are not treatment inherent, all to do with the problems that you raised. And of course, you know as well as I do that a lot of work has been done in the US about reflect on how you could maybe persuade funders to tackle that one issue. That really, I think, is the key issue for us at the moment.
I think you're right. I think that the outcome measures are a big issue. I think the difficulty is that there's always a tension between having an outcome measure that really is important versus the ones that are important to the participants in the research program. So, for example, GCSE is a priority for teachers in secondary schools, and therefore they're going to be attracted to anything that might give them better GCSE results. I think my experience of working in schools over the last 30 years is it's very hard to get teachers interested in improving performance on anything other than the things that they think they're being held accountable for. So I think we should be doing that work, but I think the hardest bit is not going to be doing that work, it's going to get people to participate in experiments that use those kinds of measures. So we maybe have to have dual measures. Maybe we have the ones that they care about and the ones that we care about. But then, of course, you've got the issue of how do we decide what it is that this education is meant to change? I see that's we can't even get people to agree on what education is for. So,
Mostly childminding.
It's a hugely important issue. Maybe I haven't done much work on it because it seems ferociously difficult.
Okay. Now, no one's waving at me with another question, so I think we've got a couple of minutes, maybe just a final. If there's anything you're bursting to say from people on the panel to summarise, or anybody else. Otherwise, no, nobody's meeting my eye. They obviously don't have it. Yes, right, Laura, one final question.
Yeah, just one final question. Obviously, there's the toolkit. I'm just curious, how do you balance the caveats that we've been discussing and the accessibility of meta-analysis with those who work, educational professionals? Apart from, having a toolkit where you've got the lock system, how do you broach with them these questions of what is the best for you to be using and what, giving them that perspective and that critical awareness to deal with research?
It's a great question. Who wants to answer it?
Well, I can answer by kind of agreeing with the direction of Laura's question. Is that was some of the hardest decisions about designing the toolkit were about what are we trying to do? And for me, it was a big picture of education research. It was relational, because one of the issues with single studies is how do you decide whether a technology study is better than a math study or collaborative learning? How do you get that big picture? I absolutely take Dylan's criticisms of months' progress. I think, were we starting again, we might have perhaps started in a different place. But the idea of a single scale that would be intuitively appealing to teachers still drives my reason. And I'd echo kind of Churchill's comment. It's probably the worst way of doing it, apart from all of the others. I don't know how else we do that. So then what becomes important are the caveats that you set around that about informing professional decision making, not determining what you do. Because the other flip side that we haven't talked about at all is if the profession doesn't take control of that evidence, other people will. And policymakers will determine how the evidence is used on the profession. So that's also been driving me in what the decisions I make, is we have to maintain, if you like, educational control of that evidence, and discussions have to be done at a professional level. Now, I speak very much as a former classroom teacher, and that clearly influences my views. But I don't think we shouldn't be naive about the evidence ecology. If we don't take control of it, other people will, and we have to be aware of that.
Just to add one of the other people
very briefly,
is that as well as policy, you've also got teachers spending huge amounts of money on untested interventions. And you contrast that with an imperfect meta-analysis.
Okay, thank you for that. That's going to give us something to talk about.